Hello everyone. So today I'm going to explain you that where this line spectra is actually coming from. What is making these wavelengths to be created and these line spectra, how they are getting absorbed and these black lines are forming. So I'll explain this particular concept today. Alright. Before explaining this concept of absorption and emission, let's read these two paragraphs which are very important. Okay. Different elements emit and absorb different wavelengths as we have studied in our last lesson. To understand this, we need to establish 2 points. First, as with the photoelectric effect, we are dealing with light, okay, interacting with the matter. What was happening in photoelectric effect? One photon will come to the matter, a metal plate, it will just, the electron on the surface of your metal, it is going to absorb the photon, and that energy it will use to escape from the metal, and it is also converted into some kinetic energy, that electron. Okay, so right now, hence we need to consider light as consisting of photons. This thing is established that we are considering light as small packets, and these packets are called as photons. Okay, for light of a single wavelength lambda and frequency f, the energy of each photon, this also we have established last time, E is equals to hf, where your f is equals to c over lambda. Now, second is, when light interacts with matter, it is the electrons that absorb the energy from the incoming photons. Okay? Electron is going to absorb the energy. Okay? And light is emitted by matter in the form of photon. So basically what they are saying in this particular paragraph is that photon won't absorb the electron. Electron is going to absorb the energy of your photon, okay? And that energy, when your electron loses that energy, then it will be in the form of photon. Now you will understand that how these colors are forming, and because here we are establishing that each photon has some wavelength, and then we are also saying that when your electron is going to lose energy, it will release a photon. So photon of which wavelength will actually determine your emission spectra or your absorption spectra. We'll come to that later. Okay, so you people have studied this particular concept in chemistry also, right? When you have, for example, you have these orbits and this is your nucleus, and these are, let's say, electrons present around it. Okay, when we say that, oh, the electron is very much excited, it is going to go into the next band available. Okay, when it's 4 here or whatever, it is going to go over here, right? And when this is what we call as the energy band. Okay, this gap, complete gap between one level to another level. Okay, from lower to higher or higher to lower, there is a gap in between where there is no orbit and no electrons present. Okay, it's just space. So this electron is going, when this electron is going to absorb some photon, let me do it again, okay, neatly. Okay, so when, let's say 2 here and let's say 4 here, let's say, when it will get some energy, it is going to jump in this orbit. Okay, energy is absorbed and the electron went up. Now when the energy is going to get released, when the energy is going to get released, it will come back to its original position in the original orbit, right? It is going to come back. So when it is coming back and when it is releasing the photon, it will emit a wavelength, a frequency or a certain wavelength. Because a photon is released now, it will emit an photon and it will come back to its position. Okay, so this is how the energy level works, and this is how you are actually seeing colors of line spectra. Now it depends from element to element that what is the energy gap. Okay, in between them. It depends on it, how it is going to come back, at what wavelength it is coming back, what element you are using. That's why for hydrogen or helium, you have seen the spectra. For each element, it was different because the energy levels are different. Yeah, the number of electrons which are jumping to the high level to the low level, it's different for each element. That's why it is emitting a different line spectra. All right. One very important aspect over here, if you see this graph, they have made this graph like in physics, we don't make the circular graph, we just explain it in terms of a linear graph like this. We just make straight lines, okay? And these straight lines actually represents each orbit, okay? If in chemistry it would be like this, 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 like, okay? But in physics we don't draw like this. We make energy levels like this, okay? Okay, so right now, if you see the energy over here, yeah, it is negative. And can you see that there is a zero level also? First I'll explain. Zero level actually means that that's it, your electron escaped. Okay? Your electron is not part of this particular orbit now. Okay? Zero energy level means that khalas, here, oops, it's escaped. Alright. Now, let's read this and let's see also this negative energy, that why it is saying it is negative and why we are not considering it positive. We'll come to this as well. Now let's read from here. What does the appearance of all the line spectra tell us about electrons in atoms? Yes, they can only absorb or emit photons of certain energies. Okay? We studied this thing that for each particular element there is a threshold frequency, right? We talked about it before. For each threshold frequency, basically your photon should be that much energetic so that it has the ability to make your electron that much excited that it leaves your atom or it goes to another level. Okay? So you need that minimum amount of threshold energy. So, or frequency. They can only absorb or emit photons of certain energies, of course. From this we deduce that electrons in atoms can themselves only have certain fixed value of energies. Yes, each atom has its fixed amount of energy, which different, this is the reason one element is different from another element. This idea seems very odd to scientists 100 years ago. And there is a diagram over here which we just saw. This is the diagram for a hydrogen atom, okay? An electron in a hydrogen atom can have only one of these values of energy, okay? Like your hydrogen atoms will have only these energy levels. It won't have 0.03. In another hydrogen atom, you won't have 0.36. No, you won't have these values. It has fixed energy levels, okay? Okay. Okay, it cannot have an energy that is between these energy levels. Okay, got the point? The energy levels of the electrons are analogous to a range of a ladder, just like a ladder. You cannot have a step in between. You have this step and then you have this step. It can be irregular like this, but there is nothing in between. So you always say that it is also like an analogous or analog ladder. The energy levels have negative values. Wow, this is a very good concept. The energy levels have negative values because external energy to be supplied to remove an electron from the atom, we need some energy from outside to come here to remove this electron and just make it to the level of energy level of 0 or above 0 to the positive side. Okay, so that's why this energy level is kept to be as negative. Okay, the negative energy shows that the electron is trapped within the atom of the attractive forces of the atom nucleus. We always say that electron is actually trapped inside. In order to make it release, we need some external energy to come into action and make your energy level to the positive energy level or zero energy level so that it gets escaped from that trap. Okay? The energy of the electron in the atom is said to be quantized. This is the reason why we say it's quantized. there are certain levels, okay, and we want to go over here to another level. So whenever we are talking about levels, we are actually talking about quantization, okay. Levels means quantization basically. So the energy of the electron in the atom is said to be quantized. It is divided into proper steps, okay. This is one of the most important statement in the quantum physics. Never forget this, that the steps are actually quantized. The energy levels are quantized. You can say this also. Now we can explain what happens when an atom emits light. Right now, I just explained you guys that how it is actually going to happen. The electron make a transition to a lower energy level, right? It absorbs the photon, let's say, and from the lower energy level, it is going to get to a higher energy level. Okay, let's say, and okay, the loss of energy of the electron leads to the emission of a single photon of light. So when it is like above here, right, it has absorbed the photon and it is over here. Now it will release that particular photon and it will come back here, okay. The energy is exactly equal to the energy difference between the two levels. Yes, the energy, obviously the photon has to be of that much energy. That's why it makes it from this level to this level. If the photon was of not that much energy, it couldn't have moved this electron. If the photon has moved your electron from the lower level to the higher level, so when it is going to get emitted, it should be exactly equal to that particular amount of energy which is over here, okay. If the electron makes a transition from a higher energy level, the energy loss of the electron is larger, and this leads to the emission of a more energetic photon. For example, now they are saying that a very powerful photon, it is going to just take this over here, okay, and now when it is going to come back, it is going to release a high amount of energy, okay. So a highly energetic photon is going to get released, which will produce a different color. You know, there are two methods by which actually photons can be released. Either it can be, it depends from elements to elements. Like, let's say I am going from this particular orbit, my electron goes to this particular orbit. The electron can come like this, or it can directly come like this. It can come like this also. Like any of the form can be used, okay. So for each level going down, a different wavelength is going to get emitted. So it varies from element to element that how your energy jumps are actually getting happened, like how the electrons are actually jumping, okay. Okay. This explains why only certain wavelengths are present in emission. This is the reason that for hot gases we just saw last time, that cadmium or the helium, their line spectra were different. This is the reason, that because when it's going to come back to its original position, the electrons are coming back, so a different wavelength is going to get emitted depending on the element, and it is all programmed very well by law, that how your electron is going to come back to its position, and that wavelength declares that which color you will see in the line spectra. Okay. Atoms of different element have different line spectra because they have different spacing between their energy levels. We discussed this before, that energy levels are different. That's why different wavelength is going to get produced. It is not within the scope of this book. Okay. Yeah, what still I explain? Similarly, we can explain the origin of absorption line spectra. Now, the absorption line spectra is also very important. Emission happens when your electron gets excited, it goes up and then it comes down. It emits some lambda, some wavelength. Now, let's talk about the absorption line. Actually, the white light has like all the colors. Okay. So, which colors are exactly going to get absorbed? The colors which are exactly going to get absorbed are the ones which has exactly the same amount of wavelength or energy level that is present in that particular element. Exactly, not slightly greater, not slightly below. It has to be exactly of that energy. Now let's see. For a photon to be absorbed, it must have exactly the right energy to lift an electron from one level to another level. If it is energy is too little or too great, it will not be absorbed. This effect can also be described as a form of resonance, right? In resonance, it happens also. One frequency overlaps with the same like frequency, and then the resonance actually it is like increases, and it is going to move or bridge and stuff. We took it before as well. Okay. So this effect can also be described as a form of resonance. The frequency of the photon must be such that the energy matches the gap between this is a must. Okay, the photons has to have the energy that is exactly like this particular difference. The photon over here is going to get released with the energy of this particular gap. Okay. Now this diagram explains everything very well. How the photon emission is going to get happen when you are moving from your higher energy level to your lower energy level, a certain wavelength is going to get emitted. And we said that it also depends from element to element that how it is going to come back. It can come back straightforwardly like this, it can come back like this, and both are going to produce a photon depending on the energy level. Okay, and over here this is absorption. Photon is actually getting absorbed. Why it is getting absorbed? Because it has the same amount of energy level of this one. Okay, and over here let's say it's not getting absorbed because it is might be possible higher the energy level of stuff. Okay, so a photon, when an electron drops to a lower energy level, it emits a single photon. Okay, a photon must have just the right energy if it is to be absorbed by the electron. Okay, so right amount of energy, the electron will absorb a photon, it will jump up to one energy level to another energy level if it is of the right. This one, let's say its energy is not fine, so that's why it's not making another jump. Okay, so this is not happening because the photon energy is not that much. But here the photon energy is good. Okay, it gets absorbed and then your electron jumps to another orbit, and this on the line spectra it will give you the black line. Okay, so this concludes today's lesson. I'll upload the photon energy tomorrow. Thank you so much. Please guys study, okay?